Now, I've given you the definition of potential energy. Let's motivate using our definition of work. Let us discuss what gravitational potential energy is, the first potential energy that we will be discussing this semester. Okay, so, ayan. So, naalala ninyo from the previous discussion, the work done by gravitational force on an object. So, let's say, for example, you have an apple. Kasi si Newton pala yung nabagsakan ng apple. You have an apple with some weight which go to mg. Tapos, definitely, if if a work is done such that it will move, this apple hill will move upward, aakyat, ang mangyayari, initially, di ba, ang tendency, mabilis sa baba, pero pagdating sa taas, kung naalala niyo yung problem ng maximum height, nababawasan yung speed ng object, anong apple in that case, and therefore, what will happen is the final velocity of this particle will be zero. The final velocity. So the point here is the final velocity here is less than the initial velocity. As a consequence, the final kinetic energy is less than the initial kinetic energy. Diba? So FKF and Ki is greater than Kf. And thus, by using the work kinetic energy theorem, the work done by gravity is Ws cosine phi, and this is just delta K. And therefore, the work done by gravity is mgs cosine phi, where phi, anong phi dyan? Ang direction ng weight ay downward, pero ang direction ng displacement ay upward. Therefore, what's the angle between them? Ano yung angle between them?
180.
Yes, 180 degrees, right? They are anti-parallel to each other. So if the object is moving upward, the angle between them is 180 degrees. And thus, we can say that the work done by gravity is negative mgs. It's minus. It's negative kasi opposite yung direction ng gravitational force at saka ng displacement ng object. So, hence, gravitational force is negative. We can also see that using work kinetic energy theorem, this is delta K. This is 1/2 m v2 squared, some v squared minus v naught squared. Pero alam natin na yung v squared ay mas maliit kay v naught squared, and therefore this is less than 0. Hence, we see that in both cases, the work done on the apple is negative. Okay. What if pabaliktad naman? What if pababa yung object? Pababa si apple. If pababa si apple, now both the work and the displacement act in the same direction. And what will happen is the velocity will now increase. And thus, by work kinetic energy theorem, magiging positive ang work. So this means that for an object that's falling, the angle between them is zero, they're parallel to each other. Ang mangyayari ay, work is just mgs cosine zero, and therefore, it's positive in nature. Work done is positive. Malinaw ba to? Clear ba tayo dito?
Yes po.
I hope this is clear. Okay, thank you very much for your response. So, the work done by gravity is mgs cosine phi. And it's also equal to mg quantity y2 minus y1. Kasi alam natin na yung displacement s is from y1 to y2. So from y1 to y2. Y2 is the final position, y1 is the initial position. Okay. So in that case, kapag going upward yung apple, in summary, pag going upward yung apple, the gravitational work is negative. Whereas if the object is going downward, the work done by gravity is positive. Okay, I'll just summarize what I discussed in the previous slides. Okay, so ang nangyayari ganito. So ang nangyayari at a higher height, ang tendency ni gravity ay mas mag-act sa kanya. So mas may potential yung object bumagsak compared kapag nasa baba na siya. Kasi pag nasa baba na siya, hindi na yan babagsak, di ba? Tama ba? Yes ba? So in that case, placing an object at a higher position gives it a potential for gravity to do work on it. Ibig sabihin, mas malaki yung magiging chance na mag-act yung gravity sa kanya. I don't want to say chance, pero parang ganun mo siya isipin. Hindi siya probability eh. Ang gusto ko lang sabihin is at a higher position, gravity will have that tendency to act more on that object. Kasi pag nasa baba nga naman siya, hindi na yan lalong bababa kasi nasa baba na siya. Okay, unlike kapag nasa taas, the gravity will do work on it, has that more potential to do work on it. And for a falling object, we see that therefore, at higher gravitational potential, the work done by gravity is minimum. Therefore, it will do more work. At a lower gravitational potential, the gravitational work is more is maximum. Okay? So yon. Hence, we can define that potential as a sub-energy that is based on the arrangement of two objects. Okay, so in this case, the work done by gravity is positive, and therefore, the potential of that object decreases kasi nga, mas mataas yung potential niya dito gumawa ng work, pero dito, mas mababa na. Hence, the gravitational potential energy decreases. And we can thus define the gravitational potential energy as the formula mgy. Again, the assumption here is that y should be much less than the radius of the Earth. Dapat malapit siya sa Earth. Pag hindi, we will see that in our discussion of gravitation, which will be matagal pa yun. Maybe on December. Okay? Questions. So we can define the gravitational potential energy in terms of the work done by gravity at a certain position. So the gravitational potential energy is height dependent, where the upwards direction is taken to be positive. So positive upward ang ating convention for this particular chapter. Also, only the changes in gravitational potential energy are physical. So you can arbitrarily set the y equals 0 for gravitational potential energy. Hindi nagba-matter usually ang kung saan mo set yung 0. We will see that when we solve problems in gravitational potential energy. Hindi nagba-matter yung absolute values ng gravitational potential energy. What's the only thing that matters is the change in the gravitational potential energy, not the absolute value or the actual value of the gravitational potential energy at a particular point. Okay? Gets ba to? Malinaw to? I hope this is clear. Clear ba tayo dito?
Yes, sir.
Okay, I hope this is clear. Now, gravitational potential energy is related to the work done. As I said, remember, the work done by gravity is negative, mg. Negative because we're assuming that y2 is at a higher position. Actually, nonetheless, ang point lang ay if y2 is greater than y1, that is, if the object starts at a lower position, then it goes at a higher position, the work done by gravity is negative. On the other hand, if y2 is less than y1, that is, if you started at a higher position and go to a lower position, the work done by gravity becomes negative, and therefore the work done by gravity becomes positive. Kaya ganyan yung definition ng gravitational work. Okay. Now, of course, you can distribute mg there and say that, okay, if this position here describes the potential energy, or I should say the GPE of that object at this particular position 2, and this is the gravitational potential energy at this particular position 1, then I can say that the total work done by gravitational force is just the negative of the change in the gravitational potential energy of the object. Ito na yung sinasabi kong may ibang pinuntahan yung gravitational work. Hindi na siya necessarily para magbago yung motion ng object or magbago yung speed ng object. Ang sinasabi na dito is nagbago na yung arrangement ng object. There is now work done is just the negative change in the gravitational potential energy of the system. Clear ba yon? Hindi na siya lang double equals delta K. It's all still possible na double equals delta K. Makikita natin yan later. Pero meron ng ibang pinuntahan yung gravitational work. That is, it changes the gravitational potential energy of the system. Clear ba tayo doon? Is this clear? Clear ba tayo dito?
Yes.
Okay, I hope this is clear. Okay, recall that the work kinetic energy theorem is just W gravity is delta K, which is K2 minus K1. And since they pertain to the same gravitational work, ang nangyari, we can equate these two. If gravitation only does work on the particular particle, we can say that, okay, I can equate these two, and I can transfer this to the other side. I can transfer this to the other side, and it gives me this particular equation here. Then I can define this sum. This sum is known as your total mechanical energy. Some books will write it as ME, some books will write it as E mechanical. maybe tomorrow sa discussion ko on elastic potential energy, lalagyan ko ng e-mechanical yan. But for the meantime, since mechanical energy pa lang naman pinag-uusapan natin ngayon, the total mechanical energy E is just the sum of the kinetic energy and the gravitational potential energy, E equals K plus U graph. And hence, we can see that at the initial state and at the final state, the total mechanical energy is constant, and therefore it is a conserved quantity, E1 equals E2, or wala pa pala. So E1 equals E2. The total mechanical energy at the initial state is equal to the total mechanical energy at the final state. Questions? May tanong? So what we did is to use the definition of the gravitational work to define a gravitational potential energy and say that if only gravitational force is acting on a particle, then the total mechanical energy of the system, which is the object and the Earth object system, is conserved. Okay? Questions? Ano? Wala? Wala questions? Okay, let's proceed. So if the only force acting on the particle or on the particle Earth system is gravitational force, then the total mechanical energy is constant, that it is conserved, which means E1 equals E2, or the sum of the kinetic energy and the gravitational potential energy at an initial state is equal to the sum of the kinetic energy and the gravitational potential energy at some final state. Okay? And again, E here is mechanical energy. Again, E equals K plus U, gravitation. Clear ba tayo dito? Is this clear? Clear ba tayo dito?
Yes po.
I hope this is clear. Okay, so ganun lang. Now, of course, ang tanong nyo, what if kapag curved yung path? May effect ba yung curvature ng path na yon para masabi natin na nagbabago rin yung gravitational potential energy? Actually, we can calculate the work done by gravitational force on a given path. So what we can do is consider a particular position of the object and say that, okay, the work done on this particular position during some displacement delta S is given by W dot delta S is simply the weight is negative mg. We are assuming here that the one that's positive is upward, kaya negative yung weight mo, times j hat. So this is positive j hat here, multiplied by some displacement delta xi hat plus delta y j hat. Actually, a more formal way to discuss this is not in terms of just delta S, but rather in terms of the differential of the displacement. Dapat maliit yung differential mo dyan. Pero nonetheless, pwede mong isulat na ganyan yan. So now, we know that j hat and I hat, the dot product of them is 0. Tama? So we can just remove that and say that W dot delta S is minus mg delta y. So the point here is hindi nagmatter yung delta x. Hindi nagmatter yung horizontal position ng object, yung horizontal displacement ng object. Ang nagmatter lang ay yung vertical displacement. Hence, kahit anong galaw mo, halimbawa, ganyan-ganyan ko yan, ang importante lang yung initial position at yung final position. Therefore, it's independent of the path taken by the particle. The work is unaffected by any horizontal motion that may occur. Independent siya ng path taken by particle. That will be important when we discuss conservative and non-conservative forces. Okay, so the delta U gravity for a curved path is the same as delta U gravity for the straight path. Okay, so we have shown using this very simple exercise that the work done on a particle is unaffected by the horizontal motion. It's only affected by the vertical motion. Okay? Questions? Is this clear? Clear ba tayo dito? May tanong kayo? Wala?
None
Walang
po.
tanong. Okay. Now, as a consequence, ibig sabihin, hindi nagmamatter yung horizontal position, di ba? Therefore, the speed, so let's say a projectile is launched at some initial velocity at different angles. So, the angles lang yung nagbago, pero dapat same yung initial speed niya. So, in that case, if initial speed and initial height yung particle, what will happen is at some final height, the speed will be the same. Speed ha, hindi velocity, speed. Of course, the velocity may change because it really depends on the angle between the velocity vector and the x-axis. Pwedeng magbago talaga yan. But the speed of the object at any given point remains the same. Okay? Of course, we neglect any resistance in the process. So at any given point, at any given height, the speed at this particular projectile, they're the same. And even pagpunta pataas at pagbalik pababa, parehas ang speed yan. Iba lang ang direction. Okay? We will have an example later showing this particular property of the speed of a particle in projectile motion because sa projectile, ang nag-act lang na force ay gravity. Okay? Questions? May tanong ba rito? Are there any questions in this item?
None po.
None. So, ang tanong, paano natin i-solve yung mga problems involving energy conservation? So, we have a problem solving guide kasi maraming examples ng energy conservation at usually marami pa rin nalilito rito. Actually, scalars nga lang yan eh. So, pero marami pa rin nalilito. So, first, we make a rough sketch of the system considered and set up the coordinate system. Hindi naman nawawala yan. Lagi ko namang sinasabi yan. Since the start of the semester, we start with having a rough sketch of the system. Pero ngayon, iba na ang point of view natin. Di ba? Dati, ang ginagawa natin, after we rough sketch the system, we draw a free body diagram. Ngayon, tinanggal na natin muna si free body diagram sa proseso. Wala muna si free body diagram. Ayun, because we are dealing with energies. Ano na pumalit? Ang pumalit ay states. Ang tanong ngayon, what is the initial state and what is the final state of the system? Kasi sa energy conservation, you need to compare two states, initial and final. Minsan more than two yan. In state 1, state 2, and state 3. And if the only force acting on this particular system is gravity, then we say that, okay, the initial state has the same total mechanical energy as the final state. Ngayon, ang isang importante rito, after you identify the states of the system, pwede mo ngayong hanapin saan yung zero dyan. Remember, in gravitational potential energy, ang zero, pwede mong arbitrarily ilagay kung saan. Hindi yan fixed. Pwede mo siyang ilagay kahit saan. And the answer will still be the same. Okay? Therefore, you need to identify the different states of the system. This is also true for other problems involving conserved quantities. Makikita natin sa conservation of momentum, for example, na you still also identify different states there. Maghanap ka ng states. Then after that, you determine the kinetic and potential energies at each state. Alin dyan yung pwedeng mamatay or mag-zero? Usually naman, may nag-zero dyan. Okay? Then after that, we use conservation of mechanical energy. For this particular sets of problems, ang kailangan lang natin ay conservation of mechanical energy. Sometimes magre-refer tayo sa previous formulas na meron tayo or previous equations na meron tayo, pero for now, yun lang yung kailangan natin. And then after that, we determine the unknown quantities in the problem by solving one equation. Minsan one equation, minsan two equations yan. Pero bihirang-bihira tayo magkaroon ng two equations for energy conservation. Okay? Malinaw ba tayo dito? Is this clear? Clear ba tayo rito?
Yes.
Again, I've given you some problem-solving guides to solve for you to solve energy conservation problems. Okay, are there any questions for this particular discussion?
None.
None. Thank you.